Hey everyone, welcome back to the channel. Aditya here. Today, we are going to dive deep into a critical aspect of managing APIs in AWS API Gateway, that is, logging and tracing. And these features are essential for monitoring, debugging, and optimizing your API performance. So, let's get started. First up, let's talk about CloudWatch logs. When you enable CloudWatch logging, for your API gateway, you can gain access to detailed information about both request and response body. So in the CloudWatch, we log both the requests, what and all we're getting from the client, and also all the responses, whatever we are sending back to the client. All these requests and responses will be logged in CloudWatch logs. And the second point is this logging is enabled at the stage level, and you can choose the log level that suits your needs. For example, error, debug, or info. Okay, so for each stage level, you can enable it, and even you can set log levels like error, debug, and info. Here, the debug will give more information when compared to error and info. Okay, and you can even override these settings on per API basis. Okay, so giving you granular control over what's get logged and when. This flexibility allows you to focus on the most important data for troubleshooting and performance monitoring. Okay, so you can override these API settings, and also you got the finer granular control over the what gets logged, right? So that it is easy for us to track and monitor. Okay, and one thing to note here is we will log requests and responses in the logs, in the CloudWatch logs, so that we need to ensure any critical or personally identifiable personal identification information may be logged there. So you need to ensure that it shouldn't log those kind of information in the CloudWatch logs. To get better clarity, look at this flow diagram. We have a client and they are sending request to API gateway, and API gateway first logs that request to CloudWatch if you enable CloudWatch logs, and after that it sends that integration request to the backend. Here the backend is Lambda. So Lambda process the request and send its integration response to API gateway, and we will log that response in the CloudWatch and send back response to the client, so that we will know what goes through the API gateway and what comes out of the API gateway. Next, let's explore AWS X-ray tracing. Okay, so when you enable X-ray tracing in API gateway, you get additional insights into request flowing through your APIs. Okay, so you will get detailed request tracing, and X-ray allows you to trace requests from end to end, giving you complete picture when you used alongside with AWS Lambda. Okay, so this tracing is invaluable for identifying bottlenecks, understanding latency issues, and optimizing your API architecture. So by enabling this X-ray tracing, right, you will get these many features. You will get the detailed and additional information in a visual manner, and also combined with AWS Lambda, right, you will get end-to-end tracing. Okay, so by using this, you can easily identify any bottlenecks or understand latency issues or optimize your API furthermore. And moving on to the next slide, that is related to CloudWatch metrics. Okay, these metrics are organized by stage, and you have the option to enable detailed metrics for more granular data. Okay, so for each stage you can enable detailed metrics, and even you can get the more granular data if you enable the detailed metrics. And some of the metrics that you need to remember was the cache hit count and cache miss count. So why you need this? These metrics helps you to evaluate efficiency of your cache. Okay, so cache hit means how many times your application or your clients able to get the response from the cache, and cache miss count means how many times the cache got missed or the users unable to get the response from the cache. The request actually go back to the backend. If you have more number of cache hit counts, that means your API or your cache is performing better. And if you have more cache miss counts, that means your cache is not efficient. And the second important metric is integration latency and latency. So these latencies to measure API response time. Okay. So what is integration latency and latency, right? If you see integration latency, and if you remember, we will get integration word in API gateway. So from API gateway to the backend, how much time it took for both integration request and response, that comes to integration latency purely from the API gateway to the backend. Okay, but latency means from the client till the backend. So integration latency also included inside the latency. Okay, so that is the difference. And the next metric was count. So this is the total number of API requests in a given period. Okay, and 400 and 500 series errors. So these are like monitoring client and server side errors. So 400 is related to client side and 500 is related to server side. So these are all metrics that are available in CloudWatch metrics. So understanding these metrics is crucial for optimizing your API's performance and ensuring a smooth user experience. And moving on to the next slide, that is related to API gateway throttling. So now let's discuss throttling. Okay, usually we know API gateway imposes an account level limit of 10,000 requests per second, that is RPS, and which is a soft limit. That means that you can increase upon request. So you can increase this 10,000 requests per second throughout the account level. Remember, this is an account level limit, right? So for example, in your account, you created so many API gateways or so many APIs, right? And all these APIs getting requests, not a single API, right? All the APIs within your account getting more than 10,000 requests per second, then it will throttle. So it's a soft limit. You can increase this limit by raising a request to the AWS team. Okay. And if throttling occurs, so suppose if throttling occurs, right? Then we will get a then we will receive a 429 error, that is too many requests, which is a retriable error. So that means if you reached the throttling limit, the account limit, we will get 429. So if you remember, 429 is the throttling exception or throttling error code. Okay, so do remember, and it is a retriable. So since our account is overloaded by the so many requests, if you wait for some time and again you are the clients try to hit the API, then they will get the response back, because so at some time there may be some request got processed, so you will get that space to again process the another request, right? So to avoid these overloads, right, you can set limits at both the stage and method levels also. So you can set limit on both method and state levels also. For example, for this particular state only receives 100 API hits per second. And if you limit like that, right, obviously for each stage you are limiting only 100. So other APIs also or other API stages also able to get more requests, right? But if only one stage is getting or one API is getting 10,000 requests per second, the other APIs won't work. Or only one client is accessing it, other clients also unable to access the same API. So you need to set these limits in order to serve your API to wide number, or in order to distribute your API to wide number of customers or clients. Okay. Or even the better approach is if you define a usage plan, right? So we know that usage plan will contains the throttling and quota limits, right? As per our previous session. Then you can set throttle per customer itself, right? This is similar to lambda concurrency work. So if one API is overloaded, for example, if one customer is overloading the same API, and it can affect the performance of other APIs also. So one customer is accessing only one API 10,000 times per second, and other APIs nobody can able to access, or other clients cannot able to access the same API also. So it's better to define a user plan. In that plan, you define the customers and customer level throttling so that you can control over there how many requests can go through a particular API. Let's take a quick look at common API gateway errors. So as we seen in the previous slide, we will get 400 series errors. Usually these errors are client-side errors. 400 bad request, 403 integration error, access denied, and 429 quota exceed. Okay, and these are all client-side errors. And next one is the 500 series errors. These are common errors including 502. For example, bad gateway, and 503 is service unavailable, and 504 is integration failure. Okay, so this 504 can occur due to incompatibility output of Lambda or timeouts. So if Lambda or your API gateway get timed out, right, you will get 504 error also. So 502 is bad gateway, and 503 is service is unavailable, and 504 is integration failure. So API gateway requests have a 29 seconds timeout limit. So it's important to ensure your backend services can respond within this time limit or this time frame. Okay, so there is a time limit of 29 seconds. So your API backend, your backend won't execute more than 29 seconds. If it execute 29 seconds, it will throw 504 error. That is integration failure error, obviously. And you have seen, right, when is the 429 will come? If you reach the quota limit, that is a throttling error. Okay, so moving on to the next slide, that is related to CORS. Yes, in API gateway also we can able to enable cross origin resource sharing. Okay, so finally let's talk about CORS. CORS must be enabled, right? It is required when your API is called from another domain. Definitely, right? If you are using the same domains, then this CORS doesn't require. But it is ideal to enable it because we will use different front ends and different backends. They may be from the different domains also. In that case, it will fail because of this CORS origin resource sharing issue. So you have to enable it. So, and how API gateway handles it is, first of all, if a client send a request to API gateway, API gateway will send an options pre-flight request, right, and include headers like access control allow methods, access control allow headers, and access control allow horizon. So these are our header methods. We will include those header methods in the pre-flight request header, and right will send to the API gateway so that right it will enable CORS in the API gateway. So enabling CORS is a straightforward and can be done directly through the API gateway itself or console itself. Okay, so you have to pass this pre-flight request and with some headers in it. So I will show you how it will look like now. If you see this example, we have a client having a domain example.com, and he's trying to access an API that is in AWS API.com. So both have different domains now. So in order to access this API, right, from this cross domain, these both are two different domains. First, client will do an pre-flight request to the API gateway. So API gateway will send that pre-flight response to the client, and this pre-flight request should contain the origin details, right? It will send the origin and also an options method. And what will happen? We will get the pre-flight response where it says access control allow origin, and we will mention the origin, and for this origin which are the methods will be allowed we will mention here in the pre pre-flight response, for example get, put, delete. And once we got this pre-flight response, by using these headers we will make a get request or post request like normal requests, and responses we will return. And rom and normal request may look like this, for example get request with this host and the origin. We will get the response back since we have this access control allow origin and access control allow methods available in the pre-flight response. If the pre-flight response rejects, we cannot able to access the API. Okay, we will get into that course issue. And finally, logging, tracing, and monitoring are key to ensuring the reliability and performance of your APIs. By leveraging CloudWatch logs, X-ray, and CloudWatch metrics, along with proper throttling and error handling, you can keep your APIs running smoothly and efficiently. Okay, thanks for tuning in. If you found this video helpful, don't forget to like, subscribe, and share, and hit the bell icon for more AWS tips and tricks and tutorials. See you in the next video. Bye.